Good morning. I'm Marnus Kleinans from Mateo Education, Free State Education. I'm one of the physical science subject advisors. And today we are going to look at Newton's Law of Universal Gravitation. Right, the book that I will be using and that I will be working from is this 3-in-1 series, which most of you would have received by now. So it will be very nice for you to follow during this presentation. Okay, so I'll be working from this book. If I can start, what is the goal of today? The goal today would be to look at possible exam questions that you can expect from different topics. And for that purpose, I will be starting on page 1.13 in the book. If you want to follow there, then it will be easy for you to see where is all the important things and to make notes. And you can highlight wherever you want to, but that would be just a suggestion. Good. If we look at Newton's Law of Universal Gravitation, it's about a gravitational force. And a few characteristics of this force is that it's an attractive force, it's a non-contact force, and what is very important, it exists between any two objects with mass in the universe. So that means that between you and the Earth, there's the Earth, there's you, or between the Moon and the Earth, because both of them have mass, there will be this gravitational force, and then between any two bodies with mass. So that's just the examples that they are showing there. All right. Then what is also a characteristic is that the force of the Earth on the Moon, it's an attractive force, like we said, so it would be towards the Earth. And the force of the Moon on the Earth will be attractive force towards the Moon. Those two forces are of the same magnitude. They are opposite in direction, but they are of the same magnitude, even though the masses differ. So if you look at this example, the mass of the Earth is much bigger than your mass, but still the force with which they attract one another is the same. Right, then this force then is dependent on what? It is dependent on the masses, and it's also dependent on the distance between their centers. All right, now when we talk about the distance between their centers, one will have to be very, very careful there and read your question clearly, as you will see in a later example that I'm going to do. All right, guys, when we look at this law of Newton, there's 4 possible questions that you can get from this section. All right, what is the first question? The first question that you can get would be the definition. All right, it will be the definition of Newton's Law of Universal Gravitation. So if we look at that, it says that each particle in the universe exerts a force on every other particle. And then there's a definition. The force is directly proportional to the product of the masses and inversely proportional to the square of the distance between their centers. So there is your definition. You need to know that definition. You know by now that every question most of the time will start off with a concept or a definition. And please make sure that you study this one for the purposes of the exam. If we take that definition now into a formula, then you will see there is the formula. The force, the gravitational force, is equal to the product of the masses multiplied by a constant which we call the universal gravitational constant and divided by the square of the distance between the centers as indicated here in your books. That universal gravitational constant is 6.67 times 10 to the power minus 11, and this is given to you on your data sheet. It's on the data sheet. So make sure that you know where to find that constant. So the second kind of question that you can get then would be calculation type questions, where you will should be able to substitute some values and calculate whatever they ask. If they ask you to calculate the gravitational force between two bodies with mass, then you will calculate F, and then they will have to provide you with the masses and with the distance between the centers. G is a given like indicated. Right, if they want to know what is the distance between the centers, then of course they will have to provide you with the other information. So we will look at the calculation later on, but that is the second kind of question that you can expect. So first of all, it was the definition. Second of all, it is the calculation type question. Then if you look at graphs, and here I want to look at the formula and link it to graphs, then we will see that the force is directly proportional to the product of the masses. So that's why it's a straight line. All right. We can take it even one step further, where we can say that the force will also be directly proportional to the mass of one of the bodies. That will also be true. So as a rule of thumb, whenever that variable is to the power of 1 and it's on top of the line, then you can know it's directly proportional. The other way around, if you look what is the relationship between the force and the distance between the centers, then because of the fact that this distance is under the line, it means it will now be inversely proportional, as indicated there in your book. It's inversely proportional to the square. So that will give us a hyperbola. All right? And then if we took the inverse of the distance, then now it will be directly proportional to the inverse of the square. So make sure that you know this third kind of question, which deals with graphs. And from those graphs, you can even derive some of the information you might need to substitute it then in your formula and to find the answer. All right. So that's three of the kind of answers, questions that you can